Good. Okay. So I'm really excited to welcome Joel to talk with us today. Harrison sent out a link to his article, and I just had a chance to read it and was telling him as we were coming on and getting started that it was very helpful and very accessible. So I hope you all have had a chance to look at it. But if you have not, he is going to be kind of talking through it for a bit of the conversation today, and then hopefully we can actually have a discussion around it. And I know Harrison sent out a number of questions that I think will be really good for us to start the conversation. I think one of the things that is happening for me is that I'm getting a more and more robust understanding of DIDs by every time we have one of these conversations. And so I'm looking forward to today. I think what I learned from the article helped just sort of build that context even more. And so I'm hoping that I can come away with even just a clearer sort of two-sentence description for those folks who I encounter on a really regular basis who don't know what a DID is. So anyway, but let's jump into just kind of our quick little housekeeping stuff, and then we'll let Joel take over. As you all know and are all committed to, is that we follow a code of ethics and professional conduct. If you want to refresh yourself on that, there's a link in the agenda to it. We welcome anyone to participate in these calls and encourage that participation. However, if you're really wanting to be involved in the nitty-gritty work that we're doing, then I would invite you to sign the IPR agreement, and the link to that can be found on the website. It should be able to be found on our website too, but it also can be found in the agenda, and it will require that you have a W3C account. But just to know that that is free, and participation in the community group is also free. We do keep a recording of and minutes of this meeting, and we use Jitsi to do that. If you want to participate in the call, I'm looking through and I see most of you are familiar faces, so you know to queue yourself by just typing Q+ in the chat, and that will put you on the queue, and I will be the one today who is attempting to manage that queue. So now comes one of my favorite parts of the day, which is introductions and reintroductions. So if you are new to this group, or if you haven't come off mute in a while and you'd like to just remind us who you are, now is your opportunity to do so. So please go ahead and hit that Q+ button. Alan, I noticed you came off mute. Yeah.
Yeah, I don't usually attend his meetings, but I attend a lot of the W3C meetings where they're talking about object capabilities, just so that people don't make, I'm trying to keep people from making the newbie mistakes that I made when I was a capability newbie.
Awesome. Well, welcome. I'm glad you're here. Anyone else want to come off mute and say hello? Okay, how about how about announcements and reminders? Anyone want to add themselves to the queue for that? Clea, yes, please.
Hi, just a reminder that the Internet Identity Workshop is coming up October 10 through 12 in Mountain View, California. And early bird registration, I think, ends at the end of this week. So yeah, we hope to see you there.
I will be there. I'm really excited about it. October in Mountain View sounds like fabulous. I definitely hope to see lots of folks on this list. Any other announcements and reminders? Dimitri, could I put you on the spot to give kind of a recap of the data integrity work that you've been working on?
Sure. I think Manu might be a better candidate to do that, but so the verifiable credentials working group, the 2.0, is also developing a data integrity specification as part of its deliverables. And it is a general purpose way to sign essentially JSON objects. And there's a general mechanism and a number of specific signature suites using key types that we're all familiar with. So there's the elliptic Edwards curve, RSA, the NIST curves, and so on. The data integrity works either if you're signing linked data objects using JSON-LD, or it also works using non-linked data JSON objects using simple JSON canonicalization. So, and it's in fact that part is currently being adopted by the Fediverse, so decentralized social media such as Mastodon and others. So the specs are both the main spec and the suite specs are on track to be delivered with the rest of the working group specs.
Great, thank you. Manu.
Yeah, just to add to what Dimitri was saying. So the good news, I think, with the data integrity suites is as of last week, we only have 3 issues on the main spec and 3 issues on the ED-DSA spec that we need to resolve before we think the specifications are ready to go into the candidate recommendation phase. That's basically where you freeze the specifications completely, tell the implementers that they're ready for implementation, and to integrate them with the test suite. So the good news there is that I think we're a little ahead of schedule there. Clearly, we can't say that we're done yet. We will learn things as people more broadly implement it. But the other good news with those data integrity test suites, which were all incubated in the CCG, is that we have multiple independent implementations for them. 3 for ECDSA, 3 for EDDSA, 7 for the ones we used for the Plugfest last year. And that is without actually announcing that we're ready to have people integrate with it. So on a good glide path for those data integrity items. That's it.
Great, thank you. I've noticed that we've had a whole sort of influx of folks come in just the last little bit. And so I want to sort of come back to introductions and reintroductions and see if there is anyone who is joining us today that is new or just wants to come off mute and kind of say hello. So I'll kind of revisit that topic. All right, and I'll say again to everyone that's here now, if you have announcements and reminders, come put yourself on the queue. Okay, well then that concludes the housekeeping portion of the call today. And so I'm going to go ahead and turn it over to Joel, who is going to talk a little bit talk about DIDs with us. Joel and I practice screen sharing, so it should work well.
Hi everyone, happy to be here. So let's see if I can get the slides going. Okay, how about that?
Yep, we see them.
All right, great. So these are slides that I actually put together somewhat over a month ago, and the article published also over a month ago. So I want to just excuse in advance that this is not super fresh in my memory, but I think we can still have a good discussion. And I would also say, if that's okay, like feel free to interrupt if there's anything that's unclear as I'm going through this. I know we'll have time for questions at the end as well. Okay, so what we're going to be talking about today is something that I've called generative DAD maximalism. And this is something that kind of arose as I've been building decentralized protocols that use DADs as like the account mechanism, and struggling with kind of how to support multiple DAD methods while retaining decentralization of our core protocol. So before I jump in, just like very briefly about myself. I've been working in the Web3/blockchain space since 2015. Been working with DIDs since 2016. I was part of the Uport team, which was one of the early projects doing DID stuff back then. I'm a co-founder of a company called 3box Labs, and our main focus is building a decentralized data network called Ceramic. And Ceramic leverages DADs as like the main account model for publishing data into the network. Right, so for the agenda today, I'm going to start talking about like why DADs can't interoperate, and to dive a little bit deeper into that, like why do we need mutability in DADs in the first place? Then we'll talk about what generative DADs are and how they can be used together with object capabilities. And then we'll just have time for general discussion at the end. So for people who actually read my article beforehand, this is kind of just like a reiteration of that. All right, so let's dive in. Why can't DADs interoperate? Well, I think the main reason for this is that we have this specification that allows anyone to kind of implement DADs with whatever kind of backend that they feel appropriate. And this has led to, as many of you know, I think the number is probably way larger now, but over like 160, 170 probably at this point, DAD methods in the registry. It's great, we get to experiment a lot, but if you want to build an application, you likely have to pick one or a few methods that you support. And so why can't we support all of them? Why is that so hard? Well, different DAD methods requires different verifiable data registries. In most cases where you actually want to have a decentralized data registry, you need to rely on some sort of blockchain. So this could be Bitcoin, it could be Ethereum, it could be some other network. And in the case where you're relying on one blockchain, say Bitcoin or Ethereum, you can run this on commodity hardware, and you can potentially even support multiple different DAD methods that are supported by that individual blockchain. But if you want to support multiple different DAD methods that rely on multiple different blockchains, you're in trouble. You basically won't be able to run and resolve these DADs on commodity hardware. You need to kind of outsource that work to a server somewhere. And then we're kind of losing some of the properties of DADs that we actually want. We want them to be decentralized. We want them to be trust minimized. And in many cases, the DAD methods on like Bitcoin or Ethereum actually requires you to run a full node. It's not enough to run a light client. In some cases, a light client might be enough, but definitely not in all cases. And especially if you're trying to build like a fully decentralized application where you want the user to have kind of run the full kind of decentralized application, this aspect of like supporting multiple DIDs across blockchains is simply not going to work. And there are some great efforts to have some sort of universal resolver. I think there's like a repo that just like tries to integrate a bunch of DID methods into one single repo with a bunch of Docker images. And that's great, but the problem is you can only feasibly run this on like big servers, and you can't run an application that requires users to run this locally. That's simply too much. And so the question that comes to next is like, okay, so what does actually using these blockchains give us? And what these or blockchains or verifiable data registries allow us to do is have mutability of our DIDs. It allows us to have a history of like which keys were authorized to act on behalf of this DID at what point in time. And that's kind of why we want mutability of the DID, right? Like the historical changes of the DID enables mutability. And so I would say there are two main things. One is just key rotation. The other one is something that DIDs also allow us is to have a place to store some metadata. That's usually like a pointer to some service. I guess in general it's called services on DIDs, but pointing to some server or to some other kind of resource. And so one thing that noticed as I was thinking about this is like, okay, DIDs actually do two very different things. One is supporting key rotations, and one is having this like registry of metadata. So what I'm talking about here is mainly just like thinking about the key rotation aspects of DIDs. Personally, I'm not convinced that also having a metadata registry inside of a DID is like, we're kind of trying to solve two kind of very different problems with one primitive. But I don't want to dive too much into that right now. Okay, so there's this great article written by, I think, Wayne from Spruce ID. And there he talked about, there actually can think of different DID methods as having different traits. So all of these DIDs in this example, like did key, did pkh, web, ENS, and so on, supports the SECP256K1 key type. The key and the pkh are purely generative, and the other ones have the ability to rotate keys. So what is a generative DID method? It's basically a DID method that doesn't support any type of key rotation. Instead, you can basically generate the DID document from only knowing the DID URI itself. You can, essentially, in some shape or form, the URI includes the public key. So for did key, you actually have encoded the entire public key. For did pkh, you have encoded the hash of the public key. Okay. And so the nice property about generative DIDs is that we don't actually rely on any ledger. We can use them anywhere without needing to synchronize a blockchain or look up a DNS name like in the web or contact some centralized server. We can just use them locally. And so that's very nice. But we actually want key rotation, right? Like we want the ability to revoke keys and to rotate keys. And this is where I think the combination of a generative DID paradigm with object capabilities becomes a really powerful way of having primitives that enable each other. So object capabilities can be used to delegate control over DID in some sense. And I'm not, this is not like a talk about or like a discussion of what object capabilities are in detail. I'm just going to talk about some of the things that I've been seeing in the space. There are some emerging standards in kind of the Web3-ish community. Recap is an object capability based on sign-in with Ethereum. So basically, it makes any Ethereum wallet into a wallet that also can be a DAD and delegate control to session keys or other DADs. Essentially, could be a key in your browser, or it could be someone else's DAD. UCAN is an emerging standard in the IPFS community, and it's being used by a number of different projects. And this is based on JWTs. And we've actually been working closely with the Spruce team and the Fission team, who each are responsible for recaps and UCAN, to align the format for the recap and UCAN capabilities. So we can actually represent them in a very similar way and have interoperability between these two. Then I wanted to mention also chain proofs. And I think this is kind of critical to understand like how we can actually have something like the same properties we would have with verifiable data registry with only generative DADs and object capabilities. So chain proofs is basically an object capability that encodes a state proof from a blockchain. So for example, in Ethereum, every block there's a hash that's basically the root hash of the state of the entire blockchain. And given that hash, I can actually generate a Merkle proof that says the owner, for example, the owner of this NFT is account 0xABC. And I can verify this proof and verify that this block header is included in the blockchain for this chain proof. And I can know that, okay, this account was actually the owner of this NFT at this point in time. And this is really powerful because then I can verify any state about the blockchain using only a light client. And essentially, this enables us to have DAD methods that are based on various types of on-chain state without having to run a full node in that blockchain. And actually running one or multiple light clients locally on commodity hardware is way easier than running full nodes, which should be kind of self-evident. So just want to talk about an example of how we could use object capabilities to delegate control over DAD. Let's say here we have DAD example A, and we delegate basically the star, basically full access to the DAD B. So now essentially DAD B could do anything that DAD A could do. And this example DAD here, think of this as just like a generative DAD that doesn't allow you to do any sort of key rotation. You could think of this, for example, as like a did key. Now, did B basically just makes a write to some resource, and we call this data one. Now, at some later point in time, we issue a revocation of essentially the object capability that we gave to the DB. And this could be like either UCAN or recap, it doesn't really matter. And we revoke the access that DADB had. Okay, so and here down at the bottom we have this timeline, right? So we can see that data one was written at some point in time, and data B, or sorry, the revocation of the B happened later. Now we run into a problem here because how do I know here, if we don't have a strict sense of time, that maybe DADB did another write of data time 2, and from an external observer, I might not have seen this revocation yet. So we need some sense of time here. And if there's just no sense of time, we only have object capabilities and is data writes that happen at some opaque point in time. We can't really know like when this was revoked or not. And what this actually means is we need a verifiable data registry. We need to be able to timestamp what point in time did this revocation happen? Did this revocation happen before data 1 was written, or did it happen after? And in order to get that information, we need to have some way of timestamping. And this timestamping, yeah, it needs a verifiable data registry, but it could be a light client. We could simply just like register some Merkle key or some hash on chain that can be proven with only like client proof, similar to chain proofs that I mentioned before. But okay, like now we need a verifiable data registry. Are we just back to where we started? And we need to select essentially one blockchain, or have to have some centralized system that runs all the blockchains. Well, I think it's slightly more nuanced. So in the case where we have a mutable DID, we essentially have to pick one if we want to have it fully decentralized. To pick Bitcoin or pick Ethereum or some other blockchain, and then that's it. While in the case where we use object capabilities and generative DIDs, the generative DIDs are kind of universally compatible. We just need some code to verify those locally. Then on top of that, we're using object capabilities. In some cases, these are fully, we can use them wherever as well. In some cases, they require some sort of like client, like for example, if we use these chain proofs, if it's a chain proof of the Ethereum blockchain, then we of course need a like client of the Ethereum blockchain. But we can sort of like mix and match the object capabilities. We could potentially support across multiple chains. Finally, the revocation registry, which is what I'm calling the verifiable data registry, we timestamp these object capabilities, what point in time did it happen. Here we actually need to pick one essentially chain or verifiable data registry, which we use for our application. But as you can see, this gives us a lot more flexibility because we can have way more interoperability on these lower layers and make the constraint in our revocation registry. Right, so you might wonder at this point, like, okay, well, what if I want to use a mutable DID and object capabilities? In that case, you're kind of picking the worst of both worlds, in my opinion, because you both need to choose a blockchain system for the mutable DID, and then choose one for the revocation registry, and they kind of like have to overlap unless you want to like have this drive towards centralization because you can't run it on commodity hardware. Okay, so let's talk about examples of generative DID methods. Like, what can we actually do? What type of things is reasonable here? The two I mentioned already. State key. Most of you are probably familiar with this. Purely generative. It can work with uCancel recap. And yeah, like very flexible. Did PKH, also purely generative, works with recaps / signing with Ethereum, or there's similar things to signing with Ethereum for other blockchain wallets. The benefit of did PKH is there's already a wide distribution of cryptocurrency wallets out there that people are using, as it enables us to have wide distribution. Then there are other DID methods that are currently not generative or doesn't exist yet, but did NFT, not currently generative, but it could be changed to be made generative. We could simply use like based on the identifier, generate a static document, and then we could use this chain proof to essentially, as an object capability, have a state proof of, for example, the Ethereum blockchain that, hey, this particular address, aka did PKH, is the owner of this NFT, and potentially then delegate further to other DIDs. But we can have like a full proof of like, okay, here at this point in time, this was actually the owner of this NFT. And so you need a lifeline to verify the object capability, but the DID itself is purely generative. Very similar, we could imagine a DID method called did-EVM that on this would essentially just be like any function call to any contract on Ethereum can be used as a DID. This will also rely on this chain proof methodology. Then let's look at some kind of existing DIDs that are not currently generative, but I think we could reimagine them as generative DID methods. For example, DID DNS, right now it looks up a DNS record when you resolve it. I think, and there are probably people who can correct me on this call, but in theory, we could, I think, make an object capability that includes a DNS proof that you can verify after you're verifying the signature and kind of the delegation chain, rather than like always resolving the DID. So the DNS did document basically contains like, hey, this is the DNS record, and as long as you have another DID that can provide a delegation proof through some DNS record, we can have this. We can see that this delegation chain is valid. Similarly, with the mail-to, we could potentially do something as well using the DKIM proof to also do this kind of delegation. And I know there's a lot of nuances here that warrants more discussion, but this is more kind of as an illustrative example of how we can move more in this direction. All right, so that was all of the kind of content that I had prepared. The article, I think, went a little bit more in detail, but I hope this helped. So yeah, I'll kind of pause here and then see if there are any questions.
Great. Thanks, Joel. Thanks a lot. And before I start, the queue is already blowing up. But before I start calling on the queue, I want to just make sure that my understanding is right and have you kind of help walk me through my use case. So I have a wallet, and I use it to store primarily open badges and CLRs that are from education, transcripts, professional licenses. And we use DidWeb. So when I'm connecting with somebody who's going to issue me one of those credentials, I'm sending them my DidWeb, and they're authenticating it back and forth. But if I wanted to connect to somebody who used a different DID method, they would be like, no, sorry, we can't communicate. So your way would be basically to allow for that DID method, to allow like a connection between those DID methods so that I could use my usual DID method to connect. Is that right? And how is it wrong?
So I think actually you could maybe have some kind of Oracle system that acts as like an interoperability layer for these types of more centralized DID methods like DidWeb. DidWeb relies on the DNS naming system, and it also relies on someone running a server somewhere. But if you can have like some Oracle system that attests to like, hey, yeah, this DidWeb resolved to this DID document at this point in time, then you can sort of trust this Oracle network and use that as an object capability. So in theory, yeah, I guess you could have that sort of interoperability thing. This is not really what I was like trying to convey here. The primary thing I'm trying to communicate here is if we want to make a system that is fully decentralized and doesn't rely on kind of centralized servers to resolve DID methods, what is the kind of trade-off space, and like how can we make different DID methods as interoperable as possible? So it's kind of like the DAD space is pretty large. There's like a lot of different things. There are some methods that are like highly centralized. There are some methods that are like highly decentralized. And I know there's like someone has been working on this rubric and whatnot. But kind of what I'm trying to do is like this space of decentralized DAD methods. Like how can we make them more interoperable and make them something that we actually drive more usage of rather than just like using these more centralized DAD methods, because it's like a cop-out almost.
So maybe a better example would be someone has one of these very decentralized methods and they want to communicate with a more centralized method. They need a way to do that.
Yeah, it's more like if you want to build an application and you want your users to not rely on kind of centralized systems, but you still want to support as much stuff as possible, what are the right constraints for you to consider when you're building your application?
That's very helpful. Got it. Thank you. Okay, let me get over here to the queue. Alan.
Yeah, I wanted to talk about revocation. I think it's easier than you made out, because an object capability has to designate a specific object for it to be an object capability. And therefore, to revoke, you only have to notify the service that hosts that object to no longer honor that capability. Does that conform to what you were saying? I didn't get that from what you said.
I think that's fine in the case where you have a service, right? So, for example, in the protocol we're building, we're not assuming that there's one service that hosts your object. Your object is a self-certifying data structure that could be living at any number of nodes in the network. And so what we need is a way for any node to synchronize this data structure and be able to verify the integrity of this data structure trustlessly. And for that to be the case, we need to be able to know like what point in time when was this object capability revoked.
So this is not a mutable object then, because otherwise you have to synchronize any updates, in which case you can use the same mechanism to synchronize revocations.
Yeah, I think that's the point. Yeah, you would use the same method to synchronize revocations, but if you want to verify the integrity of historical events in this data structure, you need to know that, hey, this key B was valid at time 1. At time 2, it got revoked, and at time 3, it was not valid. And I need to have this information if I want to know that like the previous event that happened at previous point in time is still to be considered valid.
Time is a tricky thing. Whose time? The only one that makes sense, again, is the place that's going to do the update. And if that's distributed, that's a real tricky problem. There are other ways to handle it. Maybe we should talk offline. For example,
to me, this is
I was going to say, for example, a forwarding proxy that you can just stop forwarding.
To me, this is the problem that blockchains solve, right? Like, if you read the Bitcoin white paper, the way Satoshi actually describes it is as a decentralized timestamping service, and I think that's like a really powerful thing to leverage in these cases.
Right. Then you can just put the revocation on the blockchain, and when you get a request, you can see if it's been revoked.
Yeah, I think putting it on the blockchain might be expensive. What you can do is you can put a bunch of revocations in a Merkle tree, put the root of that on chain, and
Right.
have some kind of other peer-to-peer gossiping or synchronization mechanism.
Right. Okay. I have to learn more about your system, but I think that problem is not as difficult as you made it out to be, and I don't think that timestamps are. You have to think very carefully about what timestamps mean.
Mm-hmm. For sure.
Manu?
Yeah, thanks, Kimberly. This was great, Joel. I think you hit on a number of challenges that we have in the DID ecosystem. And I think it's really interesting how you broke the problem up into multiple parts, right? So one of them is it is interesting to be able to classify these DID methods by the traits that they have, right? Some would say like it's a feature set. So DID key and DID PKH's feature set is different from DID web, and which is different from DID ion and DID BTC and the Ethereum based DIDs. So I thought that was the one thing that you highlighted or re-highlighted that was really important. I thought the other really interesting thing that you're highlighting here is that there is a way to use object capabilities as a binding mechanism between two different DID methods, meaning the cryptographic delegation is a useful thing to have. And then finally, the way that you spoke about the time stamping services. And Alan, I think of them as, ordering services as well, meaning like you have to understand the order in which these things happened in, and you need to be able to anchor that to some common trust model. So I totally agree with you, Joel, that that's largely the service that blockchains provide, going all the way back to the original Bitcoin paper. I think the challenge here, this is not a solved problem, right? I mean, if we solve this problem, then that would be huge. It would allow us to potentially largely reduce the number of DID methods there are, and so on and so forth. I think that the challenge is, putting the pieces together in the right order. And it's what Alan kind of highlighted. It's like at some point, if you start depending on a time stamping service, then it raises the question, well, isn't it just easier to store all the data there as well? And as you said, Joel, well, that might, rocket the cost of the transaction up, and we don't want to do that. And a way to mitigate that is Merkle. So we've got all this stuff kind of bubbling around in the soup of potential, solutions that we could provide. And I think that one of the biggest challenges here, Joel, and I'm interested in your thoughts on this, is the complexity that this adds to implementers, the wallets and things of that nature. So we are already mired in complexity right now with all the different DID methods and requiring effectively a universal resolver to be able to resolve all of them. Do you feel like the level of complexity is the same if we did the O-Cap and delegation approach with the time stamping service versus a universal resolver? Like, how would you rate the complexity of both of those solutions? Is one easier than the other? That's it.
Well, first of all, I think I have a feeling that even if you have a resolver that is universal or whatnot, you still probably want to rely on some kind of object capabilities at some point. And now you're kind of stacking complexity on top of each other, which seems not like the greatest idea. And so my intuition just tells me, like, let's just put the complexity in the way to revoke object capabilities and keep the kind of lower level cryptographic primitives as simple as possible. I do think the object capability, registry, and like ability to revoke that is not super simple in itself to solve. Like if we want like one universal solution to that. But I think that it could potentially be something that applications chooses, like, hey, my application over here has this simple revocation approach. Another application over here has some other approach to that. But we can still interoperate on these like generative DID methods and different representations of object capabilities. I mean, I think the universal resolver approach works if you're fine with having your application rely on some service somewhere that you use to resolve DID methods. If you're not fine with that, you want more resilience and you want your application to be more of a more peer-to-peer nature, that might not be a trade-off that you want to make.
So can you give me an example of the type of use case where I would want it to be like an NFT wallet, like you talked about before, that would be maybe a place, or is there a better use case that you can help me picture?
Maybe I can give an example of how we use generative DAD methods and object capabilities in the protocol I'm building Ceramic.
That'd be great.
And then maybe expand from that. So right now, basically all accounts in Ceramic is either an Ethereum account or some other blockchain account, but a majority of them are just like Ethereum accounts. For this, we use DAD PKH. And so the normal flow when a user comes to an application that uses Ceramic as kind of a data storage network is that user arrives at the application. In the background, the application generates a session key. This session key is just like a dead key, very simple. Then the application prompts the user to sign a message. And this is a normal kind of standardized within the Ethereum community called sign in with Ethereum. And this message essentially contains this dead key, the public key that is, and it also contains a list of resources that this key is allowed to write to. You sign this message with your wallet, and the application gets the message and the signature back. And so in our case, that resource is a Ceramic URL, basically an ID for a unique resource. And as long as the key, the session key, can produce a signature that includes the hash of this object capability and also passes along this object capability, any Ceramic network peer can validate the integrity of this object capability and see that, okay, this session key is actually allowed to write to this resource. So that's how we use object capabilities right now in Ceramic. You asked about kind of, okay, what about an NFT or something like this? We could imagine instead of a resource being owned by like an Ethereum address, it could be owned by an NFT. And so in that case, we would have like one extra step of delegation. So when the user comes to an application, the application simply generates a state proof from Ethereum showing that like there's a proof from the NFT to the owner, and then there's a session key, and there's a proof from the Ethereum address to that session key. And as long as the session key can present these two object capabilities together, it can write to this resource on Ceramic. This is not something we have implemented yet, though, but it's something that we're kind of planning to do. And we want to do it in a way where you only kind of have like a light client requirement.
Okay, that's very helpful. Thank you. Dimitri?
I just wanted to add to what was said and to answer your question. So think of it as being able to delegate to NFT wallets or any kind of cryptocurrency allows you to access the audience of people who use things like MetaMask who have NFTs, right? It's less that you should choose it for a new use case and more it gives you a wider audience of people with wallets.
Yeah, exactly. As far as I know, the kind of cryptocurrency ecosystem and distribution of wallets is the largest distribution of private keys or like public key infrastructure, where actually people have control over their own keys, which I think is very aligned with what the whole kind of DAD ecosystem is trying to achieve.
Great, thank you both. Alan?
One thing you didn't mention, if you have a time stamping service, you can make short-lived capabilities and just rely on the expiration time instead of explicitly revoking it.
That's right, yeah, and that's actually what we're doing for our object capabilities that we use. However, you still need to notarize the events that you produce using that object capability. Because if I produce a bunch of events that at time 1 and the object capability expires at time 2, the time passes and now it's time 3, I send, basically my peer sends those events to your peer. From your perspective, would you see like, yeah, it's time 3, but you have a bunch of things that are signed with the object capability that was expired at time 2, so I'm not going to accept them as valid. However, if you have a proof that this was timestamped before that, you can accept those.
Right, and that's just a matter of how you handle the expiration time.
Yeah.
But it resolves the problem you mentioned of distributed resources and needing to get the revocation signal to them. You could just rely on the timeouts, the expiration times.
Yeah, I mean, unless you have an expiration time that's like too far into the future and you actually want to revoke a key.
Well, that again, that's why I don't like using expiration times, but it's certainly a good fallback. And if you have a distributed system, sometimes it's just the simplest thing. The hard part actually of the expiration time is you didn't want to revoke, so you have to reissue the capabilities. That's typically the trickiest part.
Yeah, and for us, actually, that's very simple, because if you come to an application, the application notices that the session key has a capability that's been expired. It's trivial to generate a new one and ask the user to sign a new message.
So your situation, it's actually easier than in most.
Yeah.
All right. Anyone else with a question for Joel? All right, great. Thank you so much, Joel, for coming and sharing this information with us. Oh, Ted. Yes,
just
Pete, we've added some links.
A quick request for a link to the deck.
Yeah, sure. Let's see if I can share this.
Phil, we have a couple minutes. You want to pop on and ask your question?
Thank you, but I'm pretty wiped out from COVID at the moment. So.
Oh no! Well, I'll ask it for you then.
Thank you.
Joel, Phil is wondering, does this allow you to reissue keys and map them to the deprecated key?
I'm not sure I fully understand the question, but you could definitely, I don't know what reissue a key means, but yeah, you can revoke a key and delegate the same access that that key has to a different key. I mean, in theory, you could revoke a key, then like give the capability again. Yeah, like the object capability model is very flexible.
Flexible is good. All right. Thank you, everyone, for coming today and engaging in this conversation. I learned a lot, deepening my knowledge. I'm not sure I'm ready to explain it in the elevator, but I'll work on it. So thank you again, Joel. Thank you, everyone, for coming, and we'll see you next Tuesday.
Thanks, everyone.